Hey YouTube, I'm Sergeant Indy. Welcome back to my turn-based strategy tutorial for GameMaker Studio. This video, we're finally going to get our heroes to move along a path towards their destination. First, a couple of variables. I've already got my actor parent object open. We're going to go right into the create event, and we're going to start building a very basic state machine. I'm not sure how complicated this is going to end up being in the long run, but by now it's just a couple simple states. If you had actual sprites and animations, this sort of a state machine would also be like, how'd you get all that animation working? I like to put my variables for states up at the top. So let's do state equals idle. That sounds like a good default state to have. And then down at the bottom, we're going to go variables related to pathing. Okay, so movement path equals path add, and let's hold on. Let's drag that out real long, like I do. Okay, so movement path equals path add. So think of path add sort of as the same thing as ds-list create. We're naming a variable, movement path, and we're telling GameMaker Studio that it's a path data structure rather than a normal variable. So that's all that is. So path set kind. See, we're not done with our path. We need to fiddle with it. So movement path 2. Okay, so path set kind is telling GameMaker Studio what kind of path we're making. There's two types that fit into this second argument here where I've got the 2. Type 2 is for a rigid straight line path, and type 1 makes sort of a rounded path, like as suggested by the points you give it. It's kind of weird looking. Point is, type 2 will hit every single point we give it right on the nose, and that's exactly what we want. Again, type 1 makes some weird kind of, like if you had like a point here, point here, point here, type 1 would be like, wee, and might not even touch all of them. It's weird. I haven't found a good purpose for it yet. Maybe if you wanted some sort of a Metroid style ziggy-zaggy beam. What do you call that? That's going to drive me crazy. Okay. Anyway, type 2 is what we want here. Still not quite done. So, path set closed. Movement path false. Okay, so path set closed determines whether a path is open or closed. A closed path will go to every single point along that path and then return to the first point so they can continue that path again. It's really good for setting up patrolling bad guys or meandering NPCs in certain games, but it's really not what we want here. We want an open path, a path where the last point doesn't link up to the first. So set this to false. We'll just go like do, last point, done. Okay. Move speed equals 8. Okay. We're going to move. We're going to use move speed later. This might be a little confusing because we already have a move variable. This guy up here, 5. And we got move speed, 8. What's going on? Well, as you guys already know, move, that's how many squares you can move. Move speed is, we're going to use that later on. It's going to refer to how quickly, in pixels per step, the actor moves between the squares, so how quickly they move along the path we're creating for them. So that's all done. Go ahead and leave it open for a second. Go ahead and pause if you're behind. Green check out of here, and we're going to make ourselves a draw event. So add event, where to go, draw. There we go. Dragging a block of code. Okay. Big one. Alright, so what we want to do here is we want to have our actor draw a line to whichever node the cursor is hovering over so that we can see what path they'll take. Since we have a draw event, the first thing we need to do is we need to remind this object that it needs to draw itself, because just having a draw event overwrites that default just draw yourself behavior. So, draw self. Problem is, we don't want to draw ourself first. Draw events layer, whatever we tell them to, from top to bottom. Draw like right on top of each other. I don't want our sprite for our heroes to be below this line we're drawing. I want them to be on top of it. So knock him down a few pegs, and then we're going to do a great big silly bunch of code here. So if cursor is hovering over a different node than actors. Yeah. Yeah, so if oCursor dot hover node doesn't equal no one, and oCursor dot hover node doesn't equal mat grid X, grid Y. There you go. Okay, so pretty simple, pretty self-explanatory. If it's not the same square we're currently standing in. So, I mean, what's the point in drawing a line from that square to that square? You wouldn't even see it. There's nothing to draw. And this part might look a little silly. Our whole screen is currently filled with nodes, so when would you not have a hover node? Well, in a few videos, you'll know when we won't have a hover node. So this is just covering up a future bug now. But we're ready to get started. So, first off, current equals oCursor dot hover node. And now we want to step through every node, parent to parent, until we reach the actor's node. Every node in the chain. Not every node, all of them, just every node in this parent-to-parent chain. We're going to do something a little scary here. While current.parent doesn't equal no one. Now, that's really not that scary. The while loops really aren't that scary. It's just that since they can cause an infinite loop, every time you deal with them, you should be like thinking about thin ice, you know? Be very sure. This one's going to be fine, though. Don't worry about that. Of course, those are some famous last words, right? I mean, everybody probably thinks, oh, no, this one's going to be fine. So draw, line, width, color. Okay, now this takes a bunch of different arguments. You can see them all down here. What's an x1, y1, x2, y2, a width, and then a couple of colors. Pretty simple. Here's something interesting, though. Draw, line, width, color, no U, is recognized, and that this will run. This will run just fine. But if you can't remember what it expects, it's not going to show you down here. So if you're ever like, oh gosh, man, what does draw, line, width, color want? Man, just British U. They expect a British U, and for whatever reason, only the British U is recognized by whatever this thingy down here is. So x1 is going to be our own current.x plus 16, and y1 is current.x or y plus 16. What am I doing? Okay. Now remember, our origin is in our top left, so that's what this is in reference to. This will draw a line from belly of our node to, well, belly of another node. Let's do that now. x2 is going to be current.parent.x plus 16, and y2 is going to be current.parent.y plus 16. And then our line width, let's go with 4. That's 4 pixels wide. And for colors, I'm going to go with C underscore lime. Now, if you made these different colors, GameMaker would blend them somehow. I've never had much luck with that. And honestly, I haven't really toyed around with it much. Maybe I should experiment with that more. At any rate, lime and lime, I think, works well with the color scheme that we've got presented here. Now, we need a way to break out of this node, because that's just going to, like, whoa, God, what are we doing? That's just going to keep drawing a line between these two nodes forever and ever and ever. That's bad. So current equals current.parent. There we go. So visualize what we're doing here. We're drawing a line between the current and the parent, and then we're setting the current equal to the parent. So then the parent and the parent's parent, and then we'll keep going until we reach our node and there's no more parents left, and it will stop. So anyway, friendly reminder, once again, just be careful with while loops. It's really not that big of a deal, but it is. Seriously, if you forget this line of code right here, you're just infinite loop. Just going to have to go to Control-Alt-Delete and kill it that way. Anyway, so what this is going to do, it's going to draw a line from the node the cursor's hovering over all the way back to the actor. The obvious question is, we're making the cursor draw all of the other UI elements, why not let the cursor handle this too? The answer is layering in depth. Our cursor is essentially on top of our actor, and always will be. Therefore, so will all of the stuff that it draws. So if the cursor drew this line, it'd end up drawing it on top of the actors. The green line would go from on top of the center of the actor all the way to the unknown. And that's fine, sort of, whatever. But I think the actor is more important than this line UI element and should be drawn over the top of it. It's sort of silly since our actor's just a big blue circle, but I mean, if you had a real sprite, you definitely want it drawn over the top of this line, so we're keeping that in mind. Since we want the actor drawn over the line, it makes sense for the actor itself to draw the line. All right, we're almost ready to give this a run. Our cursor needs a little bit of touch-up first. So let's green check out of here and there, and let's head into our cursor, and we're going to go into that step event. And what we're going to do is fix an issue from the last video to make sure that we can't reselect our currently selected actor. It's a minor bug that essentially allowed unlimited actions. You'd select an actor, let's say you clicked Sandy. She now has 2 actions. You would give her a single action's worth of movement, and then click her again, and that would give her 2 more actions. Unlimited power. That's a problem. So, pretty simple fix. We're going to go to mouse just MB left right here. If hover node.occupant doesn't equal no one, we're going to take all of this and we're going to build something around it right here. So if hover node.occupant, whoa, hover node, chill out, hover node, that's too many capitals, .occupant doesn't equal selected actor. Okay, and then we can put all of this there and put all of this here. Done. So if we're clicking on the same actor over and over again, we won't just be giving them 2 more actions over and over and over again. Yeah. All right, green checks all the way out. Let's run our game and give this a look. All right, let's click on Sandy. And we've got a green line. Look at that. All right, green line goes any which way it goes. That's the most optimal-ish path. Left, right, up, down. All right, that all looks like it works. Okay, so let's left-click off of here. And a question that comes to mind is, why aren't they drawing lines? Well, if no actor selected, none of the nodes have parents. And if none of the nodes have parents, then that while loop doesn't ever run. So I'll click on Sandy again, mouse around a bit. That all works just fine. What happens if I mouse over a square that's out of range? Nothing. Again, it doesn't have a parent, so that while loop won't ever run. Pretty simple, pretty little dirty, but efficient way to handle drawing the line is what we did. So let's close this out, and we're ready to deal with actual pathing. We've already set up the path variable in our actor. So let's get into the cursor and let's make all this happen. So head into cursor, step, bloop. See all of this code on the right click? We're about to change almost all of it. This bit at the top stays, this big if bit, right? This stays, right? And then this little else statement, all this at the bottom, that stays. Everything else goes. Yeah, all of it. So let's go ahead and grab from just the left side of this else all the way up to there. And if you'll notice, those are the paired squigglies. Everything between those squigglies has to go. So here's a couple seconds. Go ahead and pause it if you deleted too much. Go ahead and retype what you got here. No big deal. All right, now we've got a lot of coding to do. Not as much as last episode, but it's still a good amount. So in here, we're sort of doing the same thing we did before when drawing the line, where we did parent to parent to parent. We kept drawing that green line, and we're just sort of adding, except, well, instead of drawing a line, we're adding each node to a path. Sort of anyway. So last time it was okay to draw the line from last node, the node we were mousing over, all the way back to where Sandy was. But we can't have a path like that. If we set up a path like that, we would have the actor move, boop, way over here, and then draw back to where they were at. That would be not good. So we need to feed every node into a priority queue so that we can essentially reverse the order of these nodes. Let's set that up now. So first bit in here, current equals hover node. That's where we're hovering over when we right-clicked. Great. Current's going to hold on to whichever node we're working with, starting with the hover node, and then we'll call our queue path, since that's what we're using it to create. So let's create priority queue, and path equals ds priority create. There we go. Okay, let's put our first node in there. So add current node to queue. So ds There we go. Priority, add, path, current, and then current.g. We're doing all this based off the G-score just again. Okay, now we're going to store all of these nodes into the path queue with a priority equal to their G-score. This is kind of like a mutant offspring between our movement range script and the draw event that we did earlier. So it should look pretty familiar. So step through each node, parent to parent, until done. So while current.parent doesn't equal no one, add parent node to queue, priority. One of these days I'm going to type priority right on the first try. You guys aren't even going to believe it when it happens. Equal to parent's G score. Okay, so ds, priority, add, path, current dot parent, and then priority equal to current dot parent dot G. Great. Okay, so set current equal to current's parent, ready to go again. Exclamation point. All right, so current equals current.parent, semicolon. Great. So again, we're going to go through each and every one of them. It's going to stuff them into this priority queue with a priority equal to their G-score. And now we can bust them out of that priority queue in a proper order from, like, if Sandy's here, the node's there, we're putting them all in there in a priority queue, like boom, 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 backwards. But we'll be able to knock them out from smallest to biggest G-score and go forward. So that's what we're going to try to do now. In order to do this, we're going to bust out a new logical structure. It's called a do-until loop. It's going to perform a set of code until the specifications in the until statement are met. It's kind of a neat structure because the relevant statement is at the bottom, like this. So do, open squiggly, close squiggly, until ds priority empty path. And we could do this with, a bunch of other different kinds of statements, but, I figured it's a good time to show this one off. So what this is going to do, it's going to do everything in here until this is met. Great. So first thing, delete lowest priority node, closest to actors, store ID in current. So current equals ds priority delete min. Okay, good. Path. Add current node's sprite coordinates to selected actor's path. And that's how we're going to do this. So path add point. What this expects is an index, and that index is whichever path we're adding points to. So that's obviously selected actor dot movement path. And then it wants an x and a y. Well, where are we going to get that x and y? Well, the current x and y, because all of our nodes line up with their origin. So current.x, current.y, and then the last thing it wants is 100. Okay, let's talk about that. Obviously, the first variable is the path we're adding points to. I already kind of touched on that. The next two are the x, y. That's great. Super self-explanatory, right? The final number is like a speed factor, I guess, is a good way of putting it. So it's the speed factor to this of this particular node point, right? So in this case, 100. That means I want to move the actor. I want the actor to move towards this point at 100% of its normal path movement speed. So you could do something fancy here if you wanted to. You could check if this current node is some sort of, like, let's say if it was rubble, it's difficult terrain and it costs more to move over. Well, maybe we want them to only move like 50% of their speed over rubble. And you could totally set something up like that. I'm not going to bother with that. I think this is fine as it is, but I'm just explaining what this number is and why it's like 100. What's that? It is kind of squirrely. At any rate, we're done with our priority queue, so it's time to kill it. So let's scroll down a bit. We'll go ahead and pause if you're falling behind. Okay, good. Time to kill that priority queue we just made. So clean up priority queue. Clean up queue. There, don't have to type it. I'm going to have to type it here. So ds priority delete, or no, destroy, not delete, path. There we go. Great. Okay, so now we're going to do our good old-fashioned data manipulation. Remember what we did before where we're just like, oh, this guy's grid X is this, and now it's this. We're going to do all that again. We didn't really have to delete it before, but I figured it's easier to just follow along if we clear out all of the old code and type everything fresh rather than typing around a couple pieces we're trying to save. So here we go again. So first, clear the node of selected actor, and that's map selected actor.grid X, selected actor.grid Y, and then occupant equals no one. Update selected actor's appropriate grid coordinates. Chords, let's just leave it at chords. It's another awkward word to spell. Selected actor.grid X equals grid X. Selected actor.grid Y equals grid Y. Friendly reminder that the mouse will be hovered over where we're shipping the selected actor off to, and that's why that works the way that it does. Okay. Update selected actor's future node. So hover node.occupant equals selected actor. Great. All of that will get our data where it needs to be. Now to send our actor on its way. So let's do that. Send selected actor on its way. Exclamation point. Selected actor dot state equals begin path. Okay. That'll be the state that initializes the actor's movement along its path, and we'll need to fiddle with the actor's step event a little bit to make that happen. Let's reduce the actor's actions accordingly and wipe the nodes before we get out of here, which is probably redundant the way things are going to work out, but I just like to be sure. So, reduce selected actor's actions and wipe nodes. If hover node.g is greater than selected actor.move, there we go. Then selected actor.actions minus equal 2, because if it's greater than their move, that's a double move, so 2 actions gone, and then we'll wipe the nodes. Loop. And then else, and then in here, obviously it's less than a double move, so selected actor.actions minus equals 1, and wipe nodes. Okay, great. And finally, of course, after we're done with all of this mess, we're going to set our selected actor equals no one. That'll clear out the data for when they're on their way. Great. So that's it for the cursor object, but we're not quite done here. As I mentioned before, we're going to go back to our actor parent object. So here is this. Pause if you're falling behind. Green check out of here and here. Let's go into our actor, and we're going to give it a step event. A regular old step event, drag in a block of code. Okay, so now we need to resolve the actor's state. So here's another switch, another state machine kind of thing. Switch state, open squiggly, close stiggly, case, begin path, colon, break. And in here, we're going to do begin moving along path. And then path start, movement path, move speed. This is where we're telling them how fast to move in general along that path. 0 and true. Okay, path start. First variable is the path we're starting, obviously. Second is the speed that we want to move along that path. That's the move speed variable. We set that up earlier again. And then again, each point can have its own speed factor to adjust that speed to a point. Or point to point. When they do the adjustments, it's based off of this variable. Third variable, 0, this is end action. What the object is expected to do at the end of its path. There's a few different things you can do here. What 0 means is stop. Other options are stuff like back to path, like path back to start, like turn around and go back the path the way you came. And then there's also teleport back to start and then do the path again. stuff like that. For us, when we reach the end of the path, that's exactly where we want to be. So 0 for stop is exactly what we're going for. And then finally, this last variable, true, is whether the actor should follow the path absolute, true or negative, which would be negative would be false. True is absolute. What absolute means is that the path will go to the exact coordinates we have given to them rather than following the same shape of the path wherever they happen to be in the room. So true for absolute, that's what we want here. We don't need squirrely stuff. That's what we want. Only thing we need to do here is we obviously don't want this to run more than once, so state equals moving and break. That's it. And you can add all sorts of states to this switch statement, this little state machine we've got, depending on what your game needs. But for now, this is all we need for now, so we're done. So green check out of here, but we're not done with the actor, not quite yet. So we've set our actor along our path. But what we want, well, we want to do something when it reaches the end of its path. So we're going to create another kind of event. So add event and click other, and then way down here is end of path. Okay, so let's drag in a block of code to here. Now, what an end of path event is a special kind of event that Game Maker Studio will run when our actor is at the end of their path. Pretty self-explanatory, but also pretty neat. So in here, this is as soon as we finish with our path. What we're going to do is we're going to reset the actor so that it's ready to go again. So the first thing we're going to do is clear out all the data in our path. We want to get rid of all the old points so we can accept new points. So clear path, clear points, movement path. Great. Okay, I think that's pretty self-explanatory what that's doing. Now we're going to reset the state. So state equals idle. Great, get them out of moving or whatever it was we left them at. Finally, we're going to pass the actor's ID back to the cursor if it has actions remaining. So if actions greater than 0. That's not what I wanted. There we go. Hey, there we go. So cursor dot selected actor equals ID. Movement, and of course, we've given our ID back to the cursor. We need to do movement range again. So movement range, and remember there's 3 things that are expected here. The node that we're using as an origin, so map, grid X, grid Y, our move, and our actions, both of those variables. Great, that's done. Green check all the way out of here. And I'm going to run it and hope we don't have any serious errors. We shouldn't, but we'll see what happens. Okay, great. Everything looks like it's working so far. Let's cross our fingers, because it might still break when I click something. Let's left click on Sandy, and I'm going to move her short. Oh, there she goes. She moves. She reselects when she's done. We're showing yellow. Great. I'm going to move her somewhere else to finish off her actions. I'll move her here because that's a bit more interesting, kind of a curved path. And she follows it just like that. Now let's move Danny somewhere long in the yellow. Let's move him there. He's trying to avoid the rubble because it's not cost efficient to move through it. If you put him through here, he'll move through it. But let's move him around that rubble. Let's move him to here. And nobody cares about a Java update. No one has ever cared about a Java update. Anyway, so yeah, let's just go ahead and keep moving around a bit. And, you know, if you move Danny long, he doesn't reselect because he's done. He's out of actions. And you might notice there's a couple of problems. So first, let's move Danny. If we move Danny short, he automatically reselects, right? If we select Sandy and then select Danny again, well, now he's got 2 actions again. I thought we just tried to fix that in the code, right? What's wrong here? Okay. The second issue here is if I right-click and see if I can quickly... Okay, yeah. You see how, like... Let's see if I can do it again. Try to move Sandy and then click Danny while she's moving. Yeah, well, that's obviously not right either. What's going on? This is silly. All right, so this all looks like a problem, but it's not. See, the actions are currently being handled by the cursor, and it shouldn't even be handing out actions in the first place. We're just doing this for testing purposes right now. So next video, we're going to fix this. We're going to implement a turn order, a method for the game controller to decide whose turn it is and to hand out actions appropriately. Thanks for watching, everyone. Be sure to like, subscribe, or follow me on Twitter @SergeantIndy. Leave a comment below if you run into problems, have suggestions, or just want to say hello.